Welcome back guys to this latest series on top interview coding questions which are generally asked in almost all the coding exams as well as the interviews. So let's start with today's questions. In this video we will discuss longest palindromic substring. We have to find the longest palindrome substring and we are given a string and we have to write a function for it. Okay, so let us first understand what's a palindrome. Let's take an example. Let's say ABA. Okay, so if we read ABA from left, either from left or right, it is same. So all such string which are same, if we approach from left or right, if we read from left or right, it is called a palindrome. It can be also one to one, or if we take a bigger example, it can be ABB CBBA, right? If we go from left or or from right, it's same. So it's a palindrome. Now the question demands that we have to write an algorithm to find the longest palindromic substring. Okay, let's first understand what the question demands. So let's take an example. Let S be a string and we take S as AAB CDCD. Okay, so this is the given string and we have to find the longest palindromic substring. Okay guys, so what would be the longest palindrome in this? Any guesses? Okay, so let us go by brute force approach, and brute force approach will find all the substring, all the palindromic substrings, and then we'll calculate the maximum, right? The maximum length. Okay, so substrings that are palindrome we have to find if we are going from brute force approach, and later on I will discuss the efficient approach for it. So if substring palindromes, right? Okay, so if we say, then the examples like be all the individual letters are itself a palindrome, right? So it will be B, it will be C, and it will be D, right? Right guys. And second, AA, it can be. Okay, so we have seen that there are only, okay, so there is one more, right? We can say AB, it's CDC, right? I don't think is there any other substring that is a palindrome, right? Right guys. Okay, so what is the maximum length of the palindrome? That is 3, CDC. Okay, so the answer would be longest palindromic substring would be what? CDC, and length is equal to 3. Okay guys. Okay guys, so before discussing the most efficient approach for this problem, I would like to discuss the brute force approach, because knowing brute force approach of every problem is the first step toward the most efficient solution. Okay, for the sake of time I will discuss only the approach, not the code of the brute force. Okay, so the approach would be like, we have to find all the substring. Okay, for that we have to run three nested loops, and outer door loops will pick all the substring, and we will check for all substring that if substring is palindrome or not, and this by checking we'll find the maximum palindrome substring. Okay, so the time, since there are 3 for loops, hence the time complexity would be big O and Q, right? Now, so the second approach we can use to solve this particular question is dynamic programming. Okay, so the basic requirements of dynamic programming solution is the problem must be able to breakable into sub problems, that is optimal substructure, and second one is overlapping sum problem. That is the basic funda of dynamic programming is that we can solve a bigger question by solving same type question of smaller scale, right? And we have also to observe if we can reduce the number of computation of the smaller problems, right? So if we go by dynamic programming approach, what would be the our first step? Our first step to we have to find how the recurrence relation should be, because in the dynamic programming the main thing we have to find out is the recurrence relation. Okay, so let's say we have a string. Okay, and let's say we have a string, for example a a b b c b b a a, right, d e. Okay, so this is a string we have took as an example, and we have to find the longest palindromic substring. Okay, so for any string, okay, so for any string, let's say in dp we have to find, we create a table. Okay, we create a table. Okay, we create a table, let's say dp, it's n into n, where n is the size of the length of the string. Okay, so where the first n, the first index. Okay, let's say what is dp of ij? dp of ij basically means substring substring starting at index I and ending at index j, right? So this particular cell of the matrix store that substring starting at position I, index I, and ending at index j is a palindrome or not, right? So this stores is palindrome or not, right? So you would be guessing what would the data type of this matrix. Okay, so obviously it is storing, it is a palindrome or not, yes or no, or true or false, right? So the basic data type, what would be? It's bool. Okay, boolean, right? dp of I, dp of I comma j, right? Okay, so as I said, in dynamic programming we have the most important thing is to find a recurrence relation which would give the suboptimal structure of a bigger problem, right? Means a bigger problem can be broken into same type of smaller problem. Okay, so let's discuss how to approach the recursive relation, right? For this, let's say example. For example, let's say string a a. I am making some distance for each letter for explaining better. Okay, b b c. Okay, a a. Okay, so this is the example. Let's say we also include one more letter. Oh, sorry. Okay, so if you see clearly, this is a substring that is palindrome, right? And it's obviously the longest palindromic substring, and we have to position it like this is I. Okay, this is I is equal to 0, and this is I is equal to n minus 1, where n is the length of the substring. Okay, so dp of I comma j, right? dp of, what is the dp of I comma j? What is I and j? I and j basically means I is equal to 0 and j is equal to n minus 1. That is, we have to find the longest substring which is palindrome in the whole string, right? And for this we have to see if it is true or false, right? If substring starting at I and ending at j is true or false, it is a palindrome or not, right? So it depends on two factors basically. Okay, so if we look at this string, right, a a b, let's say we look at A, B, B, C, right? So we have to find first the inner substring is a palindrome or not, and then we have to check whether the outer letter is equal or not, right? Okay, means it will be true only if dp of I plus 1 and j minus 1 is equal to true true and s of I is equal to s of j. Okay, so we have to basically find the inner substring is a palindrome or not, and then we have to find the left and right letters are equal or not. Then only by going from this side or from this side we have the same substring. Okay, so this would be our recurrence relation. dp of ij would be true only if dp of I plus 1, that is the letter next from the starting letter, okay, and the letter ending ij minus 1 is true, and s of j is equal to s of I is equal to s of j, right? And this would be our recurrence relation. So otherwise it is otherwise dp of I comma j is equal to false, right? So this would be the our recurrence relation. If this is the condition, then dp of I of j is true, right? So let's discuss the code part of this method. Okay, so we have created a function which will return the longest palindromic substring. Okay, and in this we pass a string str, right? As you can see, this str is passed to the function, right? So first let us first calculate the length of the string. Okay, that is str dot size. Okay, dot size is a C++ function, that is inbuilt function in the standard library, which returns the size of the string. Okay, and then we declare a boolean dp matrix. It is a 2D matrix which will return the results of the sub problems, and later on from that result we will calculate the solution to the bigger problem. Okay, and this is a function which sets all the elements of the matrix 0, that is false. Initially all the elements is false, right? And we declare a max length variable which is 1, right? Because any string there is a every letter is itself a palindrome. So even if there is no palindrome, there must be a palindrome of maximum minimum length 1, right? Okay, so we initialize max length with 1, right? Because each letter is itself a palindrome, right? So the first step would be to find all the palindromes which has length 1, right? So all the letters are itself palindrome, hence we initialize dp of I means starting at I, right? Let me say just a minute. Starting at I and ending at I. What it means? What does this mean? It means we are verifying each letter. Okay, and you know it's obvious that each letter is a palindrome, right? So all the elements with dp of I is true. Okay, because each letter is always a palindrome. Secondly, we would find all the substring which are palindrome and of length 2, right? So what would be the formula for this? Simple, it's very simple. If I is A, then I plus 1 must be also A, right? Okay, if let's say another example, if I is B, then next element must be B. Then only we can create a palindromic substring with length 2, right? Both the letters must be same. The same thing which we are doing here is we are creating str of I should be equal to str of I plus 1. If this is true, then dp of I plus 1 is true. It means that starting at substring starting at I and ending at I plus 1. I plus 1 means length is 2, right? So if this is the scenario, before moving ahead, I would like to mention here there is a start variable. You initialize a start variable, right? What does it mean by start? Means we have to store the starting index of the longest palindromic substring, right? So this start is initialized to 0, right? Because the longest palindromic substring may start from 0 also, right? And in this for loop we would check all the substrings that are palindromes and are of length 2, right? And I discussed it, right? So for each substring that is a palindrome, right? That is a palindrome, we are checking it here. Okay, we store the starting position, right? And maximum length is 2, right? And next, all the lengths that is greater than 2. Okay, all the substring whose length is greater than 2, are they substrings or not? Okay, we would check that. So k is equal to 3. This k means length. K is the length of the substring, and we starting k from k is equal to 3 because we have already checked all the substrings with length k is equal to 1 and with length 2, and so we will start from 3, right? And we'll fix the start. Okay, so fix the start at 0, right? Because we can have length of 3 from 0 also, from every other element. Okay, but not after n minus k plus 1, right? This you must have to understand what is the limit here. Okay, so we'll calculate the j. Okay, the ending position, right? Which is I plus k minus 1. How this is calculated, let's discuss for some clarity. Okay, so let's say we have n is equal to 5, right? And k is equal to 3, right? We have to find the length of the substring of length, right? 3. Okay, and if we start from 0, that is I is equal to 0, right? Then the ending position would be what? J is equal to 0 1 2, right? 2 3. Okay, if I starts from 0 comma 1 comma 2, then j would stop from j would be 2 comma 3 comma 4. Is that clear or not? Okay, is that clear? So the formula would be I j is equal to I plus k minus 1. Means j 2 is what? 2 is I plus k, I plus 0 plus k is equal to 3, 3 plus 0 minus 1, that is 2, right? So this is the formula we have to put for calculating the j, right? And after that we have to implement our recurrence relation. Okay, dp of, how can dp of I comma j is true? How this can be true? Only if dp of I plus 1 j minus 1 is true, and also the first string on the left and the last string on the right must be same, right? As we have discussed earlier in the approach. Okay, so if this is true, and we will find the maximum length, right? If this k means what? The length of the substring that we are running this for loop. In this iteration, what is the maximum length of the substring? And if the maximum length is greater than max length, then we would update the max length with k, right? And we will also do not forget to update the starting position, that is I. This I is simply this I, right? Okay, so this is the approach, and I hope it is very much clear to you how we are using dp into to solve this problem, right? And at last, what would we get? Okay, so after doing all the computation, the result obtained will be obtained will be first, that is start position. Okay, second result would be the max length, and this is enough for returning the string. Okay. Okay, so the result obtained from all this above part is the starting position of the substring and the maximum length of the substring, right? Which is a palindrome. Okay, so we'll simply output the print the substring. Okay, so how to print the substring, right? This right. So how to print the substring? There is a substr function in the standard C++ library in which we have to pass the this is a string, right? We have to pass the starting position and the maximum length of the sub to which we have to print that. Okay, so this is the function which prints the substring of a string, and we have to provide the starting position and the length up to which that substring is. Okay, so this is the final substring, right? If you do not want to print the substring, we can simply return. Okay, so this is the dynamic programming approach, and there is also another approach which is more efficient than dynamic programming, and I will discuss in the later videos for the sake of time.